Welcome to Chemicals. Today I'm going to discuss the very important topics. That is, there are some plots they may ask in some competitive exam regarding kinetics. So let's start. So at first we will talk about reversible reaction. Okay. I will not go through the how the kinetics is coming, how the equations are coming, but I will just only focus on the plots. So in a typical reversible reaction, A to B, if the forward rate constant is K1 and that is K inverse, so that time the K equilibrium, we all know that will be K1 by K minus 1. So now let's see at t0, if that is A, and then B will obviously be 0. But at time t, suppose at time t, the equilibrium is reached. So at that time the B is forming, that is Xe. So what will be the concentration of A? So that time A will become A minus Xe. Okay. So what will be the K equilibrium that time? That will be Xe by A minus Xe. So this is the thing. Now they may ask like this thing, okay, if your K equilibrium, they give you the K equilibrium value that is equals to 1. So what will be the plot for A and B? Okay, with respect to concentration of A and B with respect to time. So we need to remember this thing. What K equilibrium means? So K equilibrium means this. Now they have given that is equals to 1. So let me put this thing. This equals to 1. So Xe is equals A minus Xe. So that means Xe is equals A by 2. Okay. So now the concentration of A, that is, I told you A minus X. What will be this? A by 2. If you just put the value, and concentration of B, that will be only Xe. Now let's draw the plot. Okay. Now this is A. So A, and now I'm just, as both are coming A by 2, so I am putting one point, that is A by 2, that is A and that is 0. So A at equilibrium, it will reach up to A by 2, and B, it will reach up to A by 2. So this will be the plot. Okay. So again they can ask you if K equilibrium is equals to 2. So what will be the plot? That's exactly same thing you have to do. You have to be. So now, what our K equilibrium expression is? The K equilibrium expression is again Xe by A minus Xe, that is equals to 2. Okay. So Xe is equals 2A minus 2Xe. So again Xe is coming 2A by 3. So what will be our A minus Xe? A minus 2A by 3. That will be A by 3. Okay. So this is my concentration of A and this is my concentration of B. So just here draw the plot. So here it is coming like A by 3. So you need to just separate the plot into 3 equal half, A3. So this is 2A by 3, this is A by 3. Okay. Now A at equilibrium, it will reach up to A by 3. So this is your A by 3. So this will be like this. And B, it will reach up to 2A by 3. So this is your 2A by 3. It will be like this. Okay. So we will not take any example in reversible. Whatever K equilibrium they will give, you just go through this and you will reach upon your desired plot. Okay. So now let's talk about parallel. That is also a very important reaction in kinetics. So in case of a typical parallel reaction, A, it will go to B and C, where this is K1 and this is K2. Okay. So, like in every case, one thing I forgot to mention, that is in every, like in kinetics, whatever plot I am discussing, in everything I am considering all reactions are first order. Okay. So if they ask you, they don't ask generally. If they ask you, so then different thing happens. So they will basically ask you in first order reaction. So here all things are in first order. So now in parallel reaction case, you need to understand, like you need to understand or remember one thing, that is in any instant, B, concentration of B and concentration of C, these two will be a constant value, which will be equals to K1 by K2. Okay, and this is called as like Weeks-Childress test for parallel reaction. Like this is a monitoring system. Okay, so in instant the scientists whoever are predicting this is a parallel reaction or whatever, so that time they are actually taking at any instant the concentration of B and C and they are measuring it, and it is coming K1 by K2. So this test, that is called Weeks-Childress test. So you don't need to remember this thing. This is okay, unnecessary and all. So this is the thing BC, that will be a constant and that will be equals to K1 by K2. Okay, and one more thing, whenever like at T is equals 0, so if A is equals to, like concentration of A is A and concentration of B and C at T is equals 0, that are 0, 0, but at T infinity, that is 0, that A, and B, like B is reaching to B infinity and C is reaching to C infinity. So one thing, that is from A, B and C are forming. Okay, from A, B and C are forming. So whatever, like what is the thing in B infinity plus C infinity, that will be must be equals to A, which is the the initial concentration of A. So these two equation you need to remember in parallel. Whatever graph we are giving you, just if you can remember these two things, then it is okay. Then you are done. Okay. So I am writing these things again here, like B and C will be K1 by K2 and B infinity plus C infinity, that will be equals to 1. Now they will ask you, like if K1 is 2K2, so then what type of plot you will expect. Now you all know this thing. So B, and I already told you at any extent BC, concentration or ratio of the concentration of B and C will be equals to K1 K2. So I am taking this is B infinity and this is C infinity. So that is equals to, I told you, K1 by K2. So what is K2? Like what is K1? That is 2K2 by K2. So that is 2. So B infinity, that will be 2C infinity. Okay. Now you have one more equation, that is this. So B infinity plus C infinity, that is equals to A. Now we just replace this 2C infinity plus C infinity, that will be equals A. So what will be your C infinity? That will be your, like, A by 3. Okay. So if this is A by 3, then B, what will be your B? Sorry, what will be your B infinity? That will be just A minus this. That will be 2A by 3. Okay. So now let's draw the plot. What are the things I have? These two. That at infinity, C will reach up to A by 3 and B will reach up to 2A by 3. Now this is my plot. So here A is only decomposing and B and C are forming. So again A3 to A by 3. So let's make the plot into 3 equal part. If this is A, this is 2A by 3, this is A by 3. Okay. Now A will always decomposing, and at infinity this will be like, this will reach, will try to reach 0. Now this is my 2A by 3. Now what the case of B? B will reach up to 2A by 3. So at infinity it is trying to reach this, and C, it is trying to reach A by 3. Okay. So this is the thing. So you can easily do this. If they ask you like 1 by 2 or 1, so that time you just replace this thing and you can reach upon this. So now I will talk about the last reaction, last special type of reaction in kinetics, that is consecutive. Okay, excuse me for the marker. So now let's talk about consecutive reaction. So what a typical consecutive reaction looks like: A to B to C. Like they will give you K1 and K2. Okay. So here like some interesting thing is happening. So at a time the B is forming and this B is again like decomposing. Okay. So the plot, just a simple typical consecutive reaction plot, what should it look like? Like A will like every time it will like be just first order decomposing curve. Now in case of B, so B is forming and again decomposing. So one thing like this concentration, that is sometimes it is again like at the first time that is increasing. So after a time, whenever like some B is formed, that time C is decreasing. So it should go through a maximum. Okay. So what it should look like it should, I told you at first it will increase, but after that it should decrease. So it will be like this. But in case of C is only again forming. But there is a time lag. There should be a time lag. Why? Because at first you should like B should form now. How it can form like C? If B is not forming, then C should not form. So there will be a time lag. So at a time lag, it is only forming like this. So this is your A, and this is your C, and this is your B. Okay. So there should be a maximum, and there are some equations so you can get what is the B max value. So whatever. But the thing is, they will ask you if K1 is very greater than K2. So then how the plot should look like. So that's the question. So here they are telling K1 is very greater than K2. So the the concentration of B that is forming, that is very high with respect to the decomposing, because K1 is very high. So if K1 is very high and K2 is very less, that means C is not that much high. So C will not be like this. So what the plot should look like? Okay. So B is forming. So B is like very high, but C is not. C is will be very small. So this is B, and this is C. Now, if they told just exactly the opposite thing. Sorry, this is K1. Pardon me for the waste of thing. That is very greater. K2 is very greater than K1. So now what's the case? Now K2 is very big, so that means C is forming very fast. So whatever B is forming, that is exactly in the next second it is going to forming the C. So that means the concentration of B in the reaction at any extent, that will be very less. Okay, and C will be very high. So A is okay. Always A will be always like the same thing. Now you just need to think about B and C. So this time I told you whatever B is forming, that is going to C. So the concentration of B will be very less. But the C, and C in every time it should have some time lag as always. So C will be high, like that. Okay. So this is the B and this is A, and the other thing is C. So that's all for today. Today I will not discuss anything. Other things are coming. Just be with us and keep sharing. Thank you.